Hi, this is the video for Chapter 1, the fourth video in Chapter 1, and it covers Section 1.4 and 1.5. So actually 1.4 is talking about multiplication of integers, and 1.5 is division of integers. And so they're in, both of those sections combined are in pages 22 to 33 of your book. If you're looking for more examples or you're looking for the homework, you can always look there. So in this section, these two sections, we're going to write and solve expressions involving multiplication and division of integers. So you can split that up into two targets if you want, or you can just leave multiplication and division combined. So the rules for multiplication and division are really, it's the same rule that applies to both of them. And I'm going to give you the rule in a story. So follow along with me. Here's the story that will help us remember the rule for multiplying and dividing integers. So this story is about integers who went to a party. And everybody was having a great time. Everybody was having lots of fun. Everybody was happy, having a good time. Everybody was positive. And then a negative showed up. So somebody who was kind of a bummer, a grouch, showed up. And the grouch went around and just complained about everything and brought everybody down. So everybody started to not have a good time at the party anymore because that one negative was there ruining everything. But wait, another guest came, another negative person showed up. So now there's two negatives. And the two negatives got together. And because they were alike, they started to smile and have a good time just because they had another negative person to hang out with. So the party was saved. The pair of negatives turned positive because they had each other. And the party, everybody went back to being positive again. So now that the two grouches were together, the rest of the people, who were really positive all along, became happy once again. So the moral of this story, and we're going to fill this in on your note sheet. The moral is, when multiplying and dividing integers, if you have one negative, it's going to make the answer negative. It's going to ruin the whole party, make everybody negative, and make all the positives negative. But if you have two negatives and you're multiplying or dividing those, they, because they have each other to hang out with, will make it a positive answer. They'll turn the party positive again, as long as there are two negatives to hang together. So I'm on your note sheet. Think of the party story I just told you. For multiplication and division, same rule for both of them. If the signs are the same, so if I have a negative times a negative, right, two negatives hanging out together, or just positives, my answer is going to be positive. But for multiplication and division, if the signs are different, so if I have a negative that comes to the party and hangs out with a positive, if I have one of each, that negative's going to bring the answer down and your answer's going to be negative. So you really just have to look and see, are the signs the same? Your answer is going to be positive. If the signs, one of each, signs are different, your answer is going to be negative. So these next sections just have practice for you. I'm going to do a couple and then let you practice. So I'll do the top row of each one. 8 divided by negative 4, signs are different. So I do the division, but my answer is going to be negative. Negative 15 divided by negative 3, right away the signs are the same, so I know my answer is positive. And 15 divided by 3 is 5. Negative 10 divided by 5, I've got one of each. The signs are different, so my answer is negative, negative 2. And 0 divided by negative 7. Well, 0 divided by anything is just 0, and 0 can't be positive or negative, so we just say it's 0. Okay, pause, and you can do this row right here. So there's the answer to this row. In each of these, I actually had one positive and one negative, so all my answers are negative answers. It doesn't matter whether the positive comes first or second. As long as you have one of each, it's a negative answer. So let's go on to the multiplication. If I am multiplying 4 times 3, I get 12. One of each, one positive, one negative, means a negative answer. 6 and 5 multiply together to make 30, but one of each, one negative, negative answer. Negative 8 times negative 2, 16. And a negative times a negative, the signs are the same, so it's positive 16, which you don't have to write the plus sign, but it's just 16. And 9 times 6, both positives, I get 54. So try this row right now. And then we'll come back and check the answers. Pause. Okay, here's the answers. I had 0, again, just gives you 0 for the answer, but it's not positive or negative. 2 negatives make a positive answer. 2 positives make a positive answer. And 1 of each, negative answer. Okay, move down a little bit, and I want to talk about some special cases. We've reviewed exponents a little bit. Let's work through these examples, because when we put exponents and negatives together, it can get a little confusing. When you see it like this is just going to be 5 times 5, so I get 25. This, same thing, still just going to be 5 times 5, 25. So those actually will give you the same answer. When I come over here, though, I actually get something a little bit different. This means to do 5 times 5 first, which is 25, and then make it the negative. So I get negative 25 as a final answer here. This one means do negative 5 times negative 5. And a negative times a negative actually gives me positive 25. So because the negative is inside or outside of the parentheses, changes my answer here. Over here I have to the third power, or I'm doing cubed, so negative 5 cubed. This would mean 5 times 5 times 5. So 5 times 5 times 5 is 125. And then put the negative out front, negative 125. This one means negative 5 times negative 5 times negative 5. So I would go left to right. Negative 5 times negative 5 is 25. Then multiply that by negative 5, and I get negative 125. And then this one, it would be the same answer here, because I have negative 5 cubed. I'd still get negative 125, but then I need to take the negative of that answer. So a negative of a negative, my final answer for this one would be 125. I don't want you to get confused. That was the answer to, let's call this part B. Here's the answer to part C, 125. So pause it and try your answers now with the 3s and just make sure you get the right answers. So pause and then check. So both of these, you're just doing 3 times 3. They're both positive 9. This one I do 3 times 3 first, but then it's the negative of that, so negative 9. And here I'm actually doing negative 3 times negative 3, which 2 negatives multiply to make a positive. Over here, this is 3 times 3 times 3, and then take the negative of that answer, so it's negative 27. This one is negative 3 times negative 3 times negative 3, which is going to end up being negative 27. And then this one means take the same answer you did up there, but then the negative of your final answer, and the negative of a negative answer is going to be positive 27. So then I wanted to talk in case C and D down here, looking at these guys. It doesn't matter if you had a negative divided by a positive or a positive divided by a negative. Either way, these are both negative answers. I have a negative and a positive, negative answer. A positive and a negative, negative answer. So it doesn't matter when you write fractions if you put the negative on the top or the negative on the bottom, or just the negative out front of the whole thing. All of these are negative 2/3, and they're all equivalent. They're all equal to each other. Same thing here. I can put the negative out front. I can put the negative on the 1. I can put the negative on the 6. They're all writing the same thing. They're all the same value. So don't get confused if you see the negative in different places. This is still just a negative 1/6, and so is this. If you turn the page, we have a little bit more practice. I'm going to talk through this top section, and then you can do the next section as practice. So this means negative 3 times negative 3. That would be a positive 9. This means I have to do the exponent first if I follow order of operations. So 3 times 3 is 9, and negative of that would be negative 9. This means negative 2 times negative 2 times negative 2. Well, negative 2 times negative 2 is 4. Times negative 2 is negative 8. This, do the exponent first, and then take the negative of that. This one, negative 4 times negative 4 is 16. So I'm going to do negative 3 times 16, which is negative 48. This one is negative 7 times negative 7, so 49 times 2, which is 98. this absolute value, well, absolute value of a negative is just the distance away from 0. So 3 times negative 6 would give me negative 18. This one, whenever you see a number outside of parentheses, it means you're multiplying those together. So negative 5 times negative 2. I also have to multiply these numbers together. This would be, I can think of it two ways. I can say, okay, we're going to minus or subtract that. So minus negative 12. Or you can say this is a negative 3 and a negative 4, and that's going to give you 12. Both of these work out to the same answer if you remember your rules for addition. So I get 22. And on this one, square. So negative 3 times negative 3 is 9. 2 times 9 minus 25. So 18 minus 25 is negative 7. So do the next section. A calculator might help you with some of the bigger numbers, or you can just do the multiplication out, but try the next section and then check. So I filled in the answers here. Take a few minutes to check them over. Make sure you have the work on your paper. If you have any questions, circle them so we can go back over them. You're going to see problems with exponents and negatives on the next quiz and in this section. So, okay, real quickly at the end we have multiplicative inverse, which is a reciprocal. It's this fancy way of saying a reciprocal, which we already covered when we talked about fractions. Another thing about multiplicative inverses are when you take like a fraction and its multiplicative inverse, or the reciprocal, and you multiply them together, it's going to make 1. So for example, 5/3 times its reciprocal, so I flip, whoop, dropped my pen. So I flip those over, and when I multiply them together, multiply across the top, multiply across the bottom, I get 1. Or 4/7 times the reciprocal, so I flipped it over, 7/4. Multiply these together to get 28, multiply these together to get 28, and 28 out of 28 is 1. So a number times its multiplicative inverse will make 1. Oops, and look at that. I already showed you the answers. So pause it right here, try these, and then come back and check them. Sorry, I wasn't supposed to show you that yet. All right, if you're already checking, make sure you, to find the multiplicative inverse, you just need to write it as a fraction and then flip it upside down. If it was negative already, it's still negative when you write the reciprocal. So like this one was a negative fraction, the reciprocal is still negative. And if you have mixed numbers, got to write it as an improper fraction first, then flip. So here's another one, a mixed number, change it into an improper fraction, then flip for the reciprocal. All right, thanks for watching. That was your notes on multiplying and dividing integers.